Hey programmers, welcome back. As promised, let's do an exercise utilizing those two-dimensional arrays. Like I always say, there's no point of just learning a concept if we're not going to actually practice it, right? As always, if you haven't given this exercise a shot on your own, I implore you to go down to the link in the description, give this exercise an honest shot, and if you get stuck, come back to this video, hit play, and I'll walk through every single problem right now. But do give it a shot on your own, right? And so for now, I'll go over this exercise. What I want to do is start with this print2d problem. So hopefully you created yourself a nice working directory that you're going to store all of your files in, and we'll work on this print2d file. All right, so it looks like in this first problem, we just have a nice little warm up. What I want to do is just write a very straightforward function that takes in a 2D array as an argument. And I want to print out all inner elements of the array, right? So if you look at the first example, I definitely have a two-dimensional array with some strings inside. And the first thing I'll notice is that for these subarrays, they don't have a particularly consistent length, right? I have like a length of 4 here, a length of 2 here, and a length of 3 over here. So I just need to bear that in mind. But in terms of the output, my function just needs to print out the elements kind of in a left, right, top, down order, right? So A, B, C, D, E, F, G, H, I, going to the left as well as downward once I finish any particular row. Let's go ahead and bang this function out. It should be pretty straightforward, very similar to what we did during lecture. And you definitely want to be sure you can solve all like the lecture code on your own as well, right? So we'll kind of go through the motions over here. So I'll make print2d. It's going to be a function who expects in array. And I know that it's a two-dimensional array, which is really just any other array, really. And let me start by iterating through the rows. So classic for loop over here. So this for loop will be iterating through every individual row. Let me save that row in its own variable, right? So I'll say let subarray equals array at index I. And maybe as a quick sanity check, why don't we just console.log subarray. I want to make sure that this code is working as I go. So I'll go ahead and just run the first example to see how my code is taking shape. So I need to cd into my working folder, which is called B2dimensional. I'm not going to run this print2d file. Cool, so here I see every single row printed out. And so that's really close. What I want to do now is just get at the inner elements, right, one by one. So now that I have the subarray, let me go ahead and just iterate through the subarray. That would just mean a separate for loop. And I need to be sure to use a distinct counter here. So I'll say let j equals 0. And here we do want to actually set j equal to 0 because that would just mean the first element of that particular subarray, right? You don't want to do that j equals I plus 1 thing. That's for like pair finding. And so we'll do j is less than subarray.length. And of course, j plus plus. A few things I want to emphasize, right? It's really important that our inner loop is really all about the subarray, right? So I should be iterating up to but not including the subarray length, as well as doing j plus plus. And at this point, to wrap that up, we just need to console.log the subarray at index j, right? Nothing too crazy. So let's go ahead and run this first example. And there I see my A through I printed out. And it should work all the same for the second example, right? It should print out some of those numbers. Cool. So that was a really great warm-up. Let's go ahead and move on to the make matrix problem. It's a little more interesting over here. And so in this function, I'm taking in 3 arguments, m, n, and value. Looks like m and n are going to represent like the dimensions of my 2D array that I'm going to return. So it should have a height of m as well as a width of n. And it should contain value as every element. This makes a lot more sense if I look at the examples over here. So if someone calls make matrix of 3, 5, the first thing I notice is the shape of the output array. So it's a two-dimensional array where there are 3 rows, right? And every row contains 5 elements. So that's kind of where like the 3, 5 pattern comes in. And each of those elements should just be a null, right? So in the same way, if I look at the second example, I have make matrix of 4, 2x. So that means I have 4 rows where every single row has 2 elements. And those 2 elements in each row are just the x character, right? And so let's go ahead and jump into this code. And I anticipate this function being a little more interesting because it doesn't expect me to like take in a two-dimensional array, but rather creating the two-dimensional array for myself, right? Based on these arguments that I take in. So I'm taking in m, n, and also the value. All right. So whenever I'm solving a function, if I don't know where to start, a nice starting point is just to think about what you should return, right? So I want to return an array. It means at some point I have to create this array. So let me create an array. I'll say I'll call it matrix equals an array. And I want to obviously add some elements into that array, and hopefully those elements are actually subarrays. But for now, let me just return that matrix, right? I'll worry about how to fill in the data in between. All right, so the first thing I want to do is maybe generate the correct number of rows based on the value of m, right? That would give me like the height of this matrix. So let me create a for loop, and this for loop just iterates through some numbers, right? I just want some code that iterates exactly m number of times, right? So what I can say is, let I equal 0 and iterate while I is less than m. And I'll do I++. And be sure to double check your data types here, right? It's totally fine to write a for loop like this because m is a number, right? So this will give me exactly m iterations, right? So in my first example, if m is 3, then my for loop basically evaluates to this. And I hit 3 different numbers, right? 0, 1, 2, because I'm excluding that actual 3, right? So I'm just going to use this for loop for the sake of iterating the correct number of times, right? This for loop iterates exactly m times. And so for each of those iterations, what I want to do is create a subarray, create that row. So what I can do is, maybe on the inside, create a subarray. Maybe I'll say row, maybe I'll switch it up. And I'll make it an empty array, right? Awesome. However, I don't just want to put an empty array into my matrix, right? Let's say we just did that. So if I did matrix.push row, so that would just give me a bunch of empty inner arrays. So let me just run the first example. This will be a good checkpoint, see how we're doing. So I should get somewhat the right shape. So I'll run make matrix. Right, so I at least have my 3 subarrays inside, but now each of those subarrays should contain 5 elements. And so I could just use another loop to push null into my row the correct number of times. So at this point, what I'll do is add another for loop. And whereas my first for loop iterated m times, I want my second for loop to iterate n times. And I'll iterate while j is strictly less than n, and of course do j++. Notice that in either of these for loops, I'm not using the counter variable I or j. I just use the for loop for the sake of how many times it iterates, right? And so now inside, what I'll do is take my row and push into it the value argument, right? So in this case, I'll be taking that null and just repeatedly pushing it into that particular row. And a few things to be super aware of here, right? Notice that my matrix.push row comes after the inner loop. Because remember, what job does my inner loop do? Well, it basically fills up a single row with all of the values I need. And only after I'm done filling up that row should I take that completed row and add it to my matrix, right? So it's really important how I have this code set up in terms of its nesting, right? So let's run this code now. Looks like we're doing good on that first example. Let's run all of these examples. So here I have my 3x5 array of null, I have my 4x2 array of x, and I have my 2x2 array of zeros. So again, key thing I want you to take away from this problem is why we put this matrix.push after the inner loop, but inside the outer loop, right? And the way I interpret it is I'm taking each completed row and adding it into my matrix. All right, so let's keep it rolling and work on this total product problem. And so in this problem, I want to do is take in a 2D array of numbers and return the total product of all numbers in that array. Recall that a product is just like the grand multiplication of all of the elements. This is just a 2-dimensional spin-off of a previous 1-dimensional problem we've done. And so all I need to do is set up some nested loops. So let me just go ahead and do that. And now that I have my classic nested for loops that iterate through a 2-dimensional array, let me just start by console.logging the inner element. So I'll print out subarray at index j. And let me just run the first example. And I should just see 1 by 1, 3, 5, 2, 6, 2, right? Just those elements printed out. Cool. Notice that I'm getting undefined because I haven't given my function a return value yet. But from here, I just want to work in that general strategy for taking like a running sum, or rather a running product, right? So as I iterate through every element of my 2D array, I want to maintain a running product. So I'll say let product, and I should declare this variable before my nested loops, right? Because I only want to initialize this product variable once, right? And a great initial value is 1, because I know that the value 1 is the multiplicative identity, right? If I multiply any number into 1, then I know that I get that number, right? Which is great, a great starting point. Obviously, if I started product equal to 0, anything multiplied by 0 stays at 0, right? So that wouldn't be a useful initial value. And so now that I'm hitting my changing elements on line 11, I'll just take that element and I'll just multiply it into my product. So I can do that shorthand of product times equals that subarray j. And after my entire nested for loops, that means I have my full product, and I'll just return product over here, right? Again, notice how I have my code laid out. This return line comes after both of my loops, because what job do my nested for loops do? Well, they have the job of multiplying every inner element into my product. And only after I've done all of the multiplication should I return my final product. So let's run both of these examples. Should get 360 and 288. And there we have it. So nothing much to these 2D array problems. We're just really extending our additional understanding of arrays. We can utilize all of the classic like problem solving logic from before, right? So hopefully this doesn't feel too new for you. Let's move on to this two-sum pairs problem, kind of ramping up the difficulty a little bit. And so what do I need to do in this problem? Well, I'm taking in two arguments, right? A one-dimensional array of numbers, that's interesting, as well as a single target number. What I want to do is return a 2D array containing all unique pairs of elements that sum to the target, right? So this is really like a spin-off of that two-sum problem. This time you want to return a 2D array, where every subarray contains two numbers, right? It contains a pair. So how can I interpret my examples over here? Let's say I'm doing the very first one, right? So this is my input array of numbers, and this is my target. And it looks like the first pair that they return is 2, 6. And that's because 2 plus 6 can actually give you 8. In the same way, 3 plus 5 can also give you 8, right? If I look at another example, let's say the third example over here, if my target sum is 11 and my numbers array is this, the only pair that adds up into 11 is the 3 plus the 8, right? So I just return that one pair. So let's jump right into this code. And this one's pretty interesting because we're using nested loops to find pairs, kind of like we did in the last lesson, right? I'm not actually going to use nested loops to iterate through a 2D array because I don't even have a 2D array, right? The input is one-dimensional. So let's use what we did in the last lesson, right? We'll say let to some pairs equals a function, takes in two arguments of numbers as well as the target. And let me start with that pair finding logic. So recall that's just a matter of using nested loops on the same array twice over, right? So let me just bang that out. And for now, let me just run the first example, and I'll just go ahead and print out what elements I hit. So console.log numbers at index I as well as numbers at index j. A few things to point out here, right? I'm using nested loops once again, but they iterate over the same array, giving me that pair finding logic, right? So let's run this and do a quick check. So here I have a lot of pairs printed out. And a keen observer might notice that, hey, this is like the nested loop that gives you pairs, but it gives you duplicate pairs, right? So I know I'm going to contain the eventual pairs that I need, like 2, 6 over here. But then later on, I would do duplicate stuff like 6, 2. And so like they say in the problem, I want only unique pairs. So I'll do that classic fix, set j equal to I plus 1, right? So I'll run this now. I have way less pairs because I only get the unique pairs. Cool. And then from here, how do I actually solve this problem, right? So I have two numbers that I want to consider. And what I want to do is check if they sum to the target, right? It's actually a pattern we've utilized before. So I'll do it over here. I'll say, hey, if I take numbers I and add it to numbers j, and that sum is equal to the target, then that's a good pair that I need to keep into my result, right? And so it looks like in this problem, what I want to do is take that pair of numbers and store it in an array of those two numbers, right? Representing that pair. So let me actually do that over here. What I can say is create an array, and I'll call it a pair, maybe just to split up this into some separate variables. And I'll say create a pair where the elements are numbers I and also numbers j. And that would represent my subarray, right? Then from there, I need to actually take that pair and add it into another array that contains all of the pairs, right? So I'll use some nice naming here. So if I find two numbers such that they sum to the target, I'll save those two numbers in their own subarray, call that a pair because there's only two elements of that subarray. But at the top, I'll create a variable called pairs, which will house all of my pairs, right? So after I generate a single pair, I'll just push it into the pairs array. Notice the singular and plural convention I'm following over here. Cool. Some pretty nested code, but if you use good indentation, hopefully it's pretty easy to follow. And that means after my for loops are done running, that means after I've checked all pairs of elements in the array, then I should just return pairs. Cool, so let's go ahead and run just the first example, let's say. So I get the 2, 6, and 3, 5, and there we have a solution for this one. And so what I want to do is maybe just clean up my code a little bit. So this code probably makes sense because we're just indexing a single array. So This pattern of writing array name, square bracket, and a number is probably very internalized right now, but maybe what I'll do is split that up into a variable. So what I'll say is let num1 equals numbers at index I. And technically I could declare that up here, right? Because I know that I doesn't change as fast as j, so I can do that up here. And then I can also say within my inner loop something very similar for j. So I can say let num2 equals numbers at j. And then from there, I can just clean up all these patterns, right? Instead of saying numbers I just say num1. Instead of saying numbers j, I just say num2. Cleaning up my code a little bit. Awesome. So let's go ahead and run all these examples now. I prefer this code a little bit more. Nice, and there we have it. Notice that in the very last example, we don't find any pairs that add up to 10, so we just return an empty array, basically saying there are no pairs, right? Which is totally fine. So as always, one thing I want to point out with a piece of code like this is it's really important that you indent your code properly. Like you may notice, every time we open up curly braces, we add a level of indentation, right? So if I look at the code that's inside of my outer loop, that would be all of this code. And I know that because it's indented at least one level inside. And for every new set of braces that I add another level of indentation. And that allows me to really easily spot the fact that, hey, like maybe lines 15 and 16 are inside of this if statement, right? Because they're immediately indented right inside of the if. All right, so let's go on to the last problem over here. Let's do this zipper.js problem. And so in this problem, we're writing a function that takes in two arrays as arguments, and I should return a 2D array containing pairs of elements at the same indices. So let's look at the first example over here. My first array contains A, B, C, D, and array 2 contains -1, -2, -3, -4. And when I pass those two input arrays into my zipper function, it should return a 2D array where every subarray contains exactly two elements and looks like it contains the elements at the same indices from both of my inputs, right? So I basically have A -1 as my first pair, B -2 as my second pair, C -3 as my third pair, and so on. So I want to get elements at like corresponding indices, right? Very similar for this last example over here. So let's step through this one. And so I'll start defining my zipper function. And so if we start with our classic tip, right, I can start by just creating an empty array because I know that I need to eventually return an array. Right, so I'll create an array. I'll say maybe just like let result equal empty array. And I'm going to return it by the end. But how should I fill up that array? And so since of course this problem is in our two-dimensional array section, you may have been tempted to actually use a 2D array here, right? But it's really important that we know how to actually apply these concepts, right, and where they're going to be useful. So recall that we use nested loops either when we're dealing with like a 2D array or when we're also dealing with like pair finding, right? You want to generate pairs. And so in this problem, I kind of want pairs, but I don't want all possible pairs, right? They tell us straight up, just give back pairs of elements at the same indices, right? So what's the pattern over here? Well, I grab the element at index 0 of array 1 and of array 2 and just put them together. Then I also grab the elements at index 1 of array 1 and array 2 and put them in another subarray. Technically, since I want elements at the same indices, I only need a single loop that can kind of iterate through both arrays at the same time, right? So the key here is just use a single for loop. So here I have my classic for loop, and explicitly it actually iterates over array1.length, but looks like in my examples, I'm going to have arrays of the same length for array 1 and array 2. So it doesn't matter if I reference array 1 or array 2 over here. I'll just choose array 1 for no particular reason. Then from there, I just want to grab elements from both arrays at the same index. So I have an index now, right? The index is I. So I'll grab an element from array 1, and I'll call that, maybe just for clarity, I'll call that my L1 for LE1, L1. I'll also do the same thing for L2 array 2. So this gives me the pattern of, oh, I have a pair of elements at the same indices. Now that I have those two elements, I want to put them as a pair in an array. So I'll create an array over here of L1, L2. I'll call that my pair. And then from there, I'll take that pair and push it into my result, right? So I can do pair, or rather result, dot push my pair. Cool. And only after I'm done pushing all those pairs into my result do I return that result. So let's run this code. I'll run zipper.js. And there I have my solution for this one. So again, key thing I want you to take away from this problem is that we did not have to use nested loops here, right? Because I wanted elements at the same indices. Recall that when you use nested loops to do like the pair finding logic, that really compares all possible pairs, right? So I only want A -1 in this problem, but if you did like the nested loop logic, that would give you A -2 and A -3 and A -4, and that would be all possible pairs, right? So really do try to understand these patterns for like this specific job they do. The nature of programming is really just pattern recognition, right? Do I understand all of these patterns for like the purpose or the problem they solve? And then when I have a new problem given to me, can I actually recognize, the different tools in my toolkit that I can use to this specific problem, right? It's never a one size fits all. I want to use the right tool for the job. All right, programmers, that's all I got for this walkthrough. What I want you to do if you had any issues with any of these problems is to redo the problem and try to do it on your own, right? Continue to use these walkthroughs if you get stuck, but please only if you get stuck. That way you can actually grow as a developer.